Hi everyone, so today we're going to solve polynomial equations and we're going to give you a few different examples so you can see how you can factor correctly and solve these polynomials. So the first thing that you have to do is remember that you have to have your polynomial equation set equal to 0. So we do need to move that 24x squared to the other side in order to get our equation equal to 0. Once your equation is set equal to 0, then you want to go ahead and see how can you factor this polynomial. So you do have a GCF of 3x. So when you take out that GCF, you get x squared minus 8x plus 7. Now you can factor that trinomial. It is a quadratic, so we can use our area model or our box. So what you have after you factor, you have the GCF still in the outside. And then you have the x minus 7 and the x minus 1. Now, when you are solving your polynomial equation, you're going to use your zero product property and set each factor equal to 0, and then solve. Now with this polynomial, it's already equal to 0, so we're good there. Now with the degree being not a 2 and it is a 4, it is a trinomial, so you can actually go ahead and factor using the same techniques with our box method, and still putting in our appropriate information. And again, finding what multiplies and figuring out what goes inside and the outsides of our box. So as we write our two factors, we have x squared plus 9 and then an x squared minus 3. So again, setting each factor equal to 0 and then solving. Now with the one on the left, we will subtract 9, take the square root of both sides. Now with 9 being a perfect square, you have a 3. And because you're taking the square root of a negative number, you will have an imaginary. So we're going to put that little I. Anytime you are solving with square roots, we're always going to have a plus minus sign in front of our answer. Now with the equation on the right, we're going to add 3. Same thing, take the square root of both sides. You will have a plus minus. Now 3 cannot be broken down, so we're going to leave it as the square root of 3. Now with this polynomial, you should see that you do have a difference of perfect cubes. So we're going to factor using a 2 by 3 box. And remembering that our diagonals must cancel because in your original equation, you do not have any middle terms. So again, putting the cube roots on the left-hand side of each term, and again, being able to fill out our boxes appropriately. So we have x squared, then you'll have negative 5x squared. Diagonal must cancel, so you got positive 5x squared. That allows you to fill out the top column. And then the bottom box. Again, that diagonal must cancel, so you have a positive 25x and then a positive 25. As you write your factors, you have x minus 5 and then x squared plus 5x plus 25. Now again, setting each factor equal to 0. With the first equation, you can add 5 to both sides and get x is equal to 5. However, in the second factor, we don't have the ability to be able to factor that more. So what's another way that we can solve a quadratic equation if we cannot factor? Would be to use your quadratic formula. So put our information of a, b, and c in the appropriate spots in our quadratic formula. Simplify your radical first. Now you do have the square root of a negative number, so you will have an I. 75 breaks down into 5 and 3. 5 goes on the outside, and then 3 goes in the inside. You will have an I. And if you could go ahead and simplify that fraction, you could, but 5 and 2 doesn't simplify nicely into nice whole numbers. So that would be our final answer. Now here are some things for you to remember. Make sure you use appropriate factoring techniques to simplify the polynomial. So think back to even when you were factoring quadratics, all those techniques you will still use when we are trying to factor polynomials. And then don't forget to set each factor equal to 0 in order to solve. Now I hope this video was helpful for you and that you learned how to solve polynomial equations with great ease. Thanks for watching and have a great day.